Let us consider some more problems on the development of solids. The problem is the one where it is stated that we have a hexagonal pyramid. So the problem says that a hexagonal pyramid of side 40 millimeters, a hexagonal pyramid of side 40 millimeters is resting on one of the triangular faces in HP, is resting on one of the triangular faces in HP, such that axis is parallel to VP, such that axis is parallel to VP. In this position, it is cut. In this position, it is cut by an auxiliary vertical plane. It is cut by an auxiliary vertical plane, making an angle of 30 degrees, making an angle of 30 degrees with VP, passing through the midpoint of the axis, Draw the development of the lateral surface. Draw the development of the lateral surface. Now, to draw the hexagon, we will have to start with the circle. As the side of the hexagon is given to us as 40 millimeters, we will be drawing a circle of radius 40, onto which I am required to draw the hexagon. Now, as the hexagonal pyramid is resting on triangular face, the rotation that we think of, the rotation of that hexagonal pyramid will be taking place about the side of the base. So we are required to have the side of the base of that hexagonal pyramid perpendicular to XY, because that will work as the line of rotation. So we will first of all draw hexagon with two sides perpendicular to XY, one of which is going to work as the line of rotation. As we are drawing the hexagon itself using the circle technique, it will not be difficult to join all the corners to the vertex, because obviously the center of the circle will represent the vertex. So I am just drawing the hexagon and showing all the generators. So initially the center line that I had drawn will be now overwritten by the generator of that particular pyramid. Now all the points of this hexagon, they should be taken up and they will be forming the base. The height of the hexagonal pyramid is not given to us. Let us take that height as, say, 90 millimeters. So we are given that height of the pyramid is 90 millimeters. So measure 90 millimeters in the front view. And as we get the vertex point in the elevation, join all the points, all the corners of the base to the vertex. Again, up till now we have not named it. So this is how we start with the solution. So we have drawn the hexagon in the top view and the triangle which will represent the front view of that particular pyramid. And now we are required to first of all name it. So I am going to name it as A, B, C, D, E and F, whereas vertex is V. So obviously the points of elevation will be A dash, B dash, this is C dash and F dash, and this is going to be D dash and E dash, and this is vertex V dash. Now we will be performing the rotation about point D dash, E dash, so that V dash point will be moved and will be shifted to XY line. So let us first of all extend XY line. So XY line is extended, and then we will perform the rotation with D dash, E dash as the center, and up to V dash it will be the radius. Draw one arc. So we get point V dash on XY. Also take distance or radius up to A dash, B dash, and cut one more arc, and then from V dash take the distance of A dash, B dash in the compass, and from V dash mark it. And so we will be getting the rotation in the front view. We will be getting the rotation in the front view, and we can also transfer the points C and F, which will be on the base. So even C and F points can also be shown on the front view. I am not yet darkening any part. So these are going to be points A dash and B dash. This is point C dash and F dash, whereas V dash has moved to XY line. Now rotation in one view is movement parallel to XY in other, and hence we will be drawing the paths through each of the points of the plan. Even the vertex, its path will be drawn, and points B and E. So all the points, their paths are drawn parallel to XY, and then through the new position that we have got of A dash, B dash, we will be dropping the projectors. Similarly, the projector through C dash, F dash, and projector through C dash, D dash will be the one which we already have, and projector through V. So we get all the projectors in the top view. To name the points, D and E remain in their position. This will be point C, this will be point D, this will be point B, this is going to be point A, and this will be point F, and this is vertex V. So let us join all of them. As we are looking from top, ABV will be the plane which is closer to the observer and will be seen fully. The base plane, which is also seen fully. Then we are required to darken the boundaries of the figure, so we will have to join CV and we will have to join FV, and the triangular plane on which it is resting, that is generator EV and DV, will not be visible, so they will be shown by the dotted line. So we are completing the top view. Now as we complete the top view, it is said further in the problem that the auxiliary vertical plane which makes 30 degrees with VP passes through the midpoint of the axis. Now axis over here is overlapped by a CF and is seen in true length in the front view. So let us mark the midpoint of the axis in the elevation. That will be the midpoint of CF over here, which will be at a distance equal to 45. Let us name it as point M dash, and then we are required to bring that particular point to the top view, because auxiliary vertical plane will be seen as line in the plan. So draw projector through M dash and get point M on the axis in top view. And then we are required to draw a cutting plane which makes an angle of 30 degrees. Obviously, I can take the cutting plane in this manner, 30 degrees, or it can be taken in this manner, 30 degrees. Remember, which portion you are removing is very important. We are looking from the base, from in this direction, away from the observer, away from the XY line. We are looking towards XY line. So portion towards the observer should be removed. And so I am choosing the cutting plane in this manner. So the section plane is passing in this manner, making 30 degrees with VP. So the cutting plane has been shown, and make the ends of that cutting plane thicker, and also indicate the portion of the solid which is retained by the arrows. So we want to retain the remaining part, and so that can be darkened now. So the portion of the top view, once the object is cut, which is remaining, that should be darkened. And so what you can see over here is this portion will be made dark. So this is the portion of the solid which is retained, and now we are required to complete or mark all these points even in the elevation. Now to mark all these points in the elevation, we will have to simply draw projectors through each of these points. Like FV is cut at this point, so transfer the point up to FV and mark the point. Then AV is cut at this point. Remember, this is AV is cut at this point, so transfer the point to AV. Then the generator EV is cut at this point, which is the hidden line, so EV can be marked, point on EV. Then generator DV is cut at this point, so that point also can be transferred. Then side AB is cut, so that point will lie on A dash B dash, and side CD is cut, will lie on C dash D dash. If at all you want to name these points, even that is possible. We can even name the points over here in the top view and try to obtain the same points, even in the front view. So we want to mark the points in the top view. So I am numbering them from left to right. This is point number 1, not to be done in the exam. This is point number 2, point number 3, point number 4, point number 5, and point number 6. Point number 6 is lying on FV. Point number 6. Point number 5 lies on AV. Point 4 on EV. Point 3 on DV. Point 2 on AB and point 1 on CD. And now these points are to be marked on the front view. We have already transferred the points. Only thing is we are required to now number them. So let us mark those points. Point 6 is over here. Point 5 on the respective lines. Point 4. Then point 3. Point 2 will be same as A dash B dash, and point 1 over here. And now the section can be shown. This is the section that will appear in the front view as we are cutting the object. This is how it will be seen in the front view, and the remaining portions of the generator, they will be made dark. Actually, a few generators, they get removed fully. The question remains as whether this portion should be visible or not. Of course, generator DV, the remaining portion of it is still present, so this also should be the portion which is dark. The question is whether this generator C6V, should it be dark? The answer is obviously no, because this portion of the vertex gets removed. You can observe from the top view that the vertex has been removed fully. So these lines should not be made dark. They are the portions of the generator which are fully removed. So this top portion does not exist. The vertex has been removed fully. And so the front view will be only the portion that I have shown. And now it should be sectioned. Hatching lines should be shown onto it, which should be equispaced and making 45 degrees to indicate the section. Remember, this section is cutting the generators, it is cutting the base also. So its development is going to be the one which is very interesting. Now whether these types of problems are asked in the exam or not, or whether these problems can be done in a stipulated time of 45 minutes is altogether a different issue, but the manner in which the particular hexagonal pyramid has been cut over here, that is very important, is going to be one of the best problems which is available for the sections of pyramids which are given for the development job. So the hatching lines are shown in the front view, and now we are required to go for the development. Now for the development, we are required to have the true lengths of all the sides. We know that there are going to be in all 6 triangles. There are going to be in all 6 triangles, and those triangles are having the base of the triangle as the base of the hexagon. They are having the base of the triangle as base of the hexagon, and the other 2 sides will be the true lengths of the generators. All the generators which we have over here, AV, BV, CV, DV, EV and FV, they have got the same length. Question is whether we have their true length with us, and you will find that none of this generator is parallel to XY, and hence we don't have the true length of any of the generator. So in this case I will be rotating say AV and making it parallel to XY in plan. So the circle was already there, so my job is slightly simpler. And then that point should be taken up, and then it should be connected to the vertex to get the true length of that generator. I am drawing it middle dark because it is a construction which will be very useful also. And so take that distance in the compass, the true length, and then using that true length draw one arc. Using that true length draw one arc where the development is to be drawn. Now generally we will prefer to have the symmetric development, so I am drawing the vertical line first, and I am supposed to draw in all 6 triangles such that the base of each triangle is measuring 40 millimeters, and 40 millimeters is nothing but the side of the hexagon, base hexagon, and take that 40 millimeters distance, and then onto this particular development from the vertical line that we have drawn, mark 3 distances on left as well as right. So 3 on the left and 3 on the right, so that the development in this case will be the symmetric one. So there will be in all 6 triangles which will appear in this view, which we are required to draw now. So all these points are to be connected to the vertex. This is again just the construction, don't darken any part, because the portions of these generators are going to get removed, and so we don't know as how much portion should be made dark. And then even the bases of these triangles are to be shown. Generally the development that we are going to draw should not be drawn in 2 parts, and hence here we will have some basic condition as from where we are going to open this particular hexagonal pyramid. You will observe that generator B and C, you will observe that the generator B and C, they are removed fully. BV and EV have been removed fully, and as these 2 generators are removed fully, they should be taking one place, one corner somewhere, and so the naming should go like so. The naming that we will prefer to have over here is, this should be generator say B, then generator C, and so this is going to be generator C, D, E, F and A. This is how we will be naming the hexagonal pyramid's development, so that now it will be in continuation. Now to mark all the points which we have got in elevation, we have got several points. These points are to be marked on the elevation, and they should be taken to the true length. Out of these 2 points I can directly mark. Out of these 2 points I can mark directly. Those are point number 2 and 1. Point number 2 can be directly taken to the side AB, and similarly point number 1 can be directly taken to CD. So point 1 in the original figure I can get, and point 2 is also easily obtainable. Remaining points I will have to transfer to the respective generators, and then this is going to be rather a reverse process, so that I can take them to the true length. Other option is you will have to construct the true length over here and then proceed along with it. Even that choice can be exploited. In whatever way, it is like I have rotated it, cut it, and then I will be putting it back and then transferring them to the true length. In whatever way we want to do it, it will be requiring the same amount of work. So 0.4 now I am transferring from here, and that 0.4 should be transferred to generator DV and generator EV. So this is taken back, point number 4. Point number 3 also has been taken back. Then you are required to take point number 5. First of all, point number 6. Point number 6 has been taken. Then point number 5. Point number 5 has been taken, and point number, okay, remaining points we have already marked. So now in the elevation we have got point number 3, we have got point number 6, we have got point number 5, we have got point number 4, and point numbers 1 and 2, they belong to the base. So I have transferred all the points to the front view in this case. So I have transferred the points back to the original front view where I have shown the true length. And now I am required to draw a path for each one of them up to the true length. So 6, then 4, then 5, and then finally 3. 1 and 2 are the points which belong to the base. So observe that I have transferred all the points to the true length that I have already found out, and then taking that particular true length in the compass, I am required to transfer all the distances, that is from V up to 6, measure the distance, and from V on the development you mark it, or you can draw the arc corresponding to that. Then for point 4 I am just going in sequence as they are present over there. So point 4, then we have point number 5, even that can be transferred. I am drawing it by arcs. Earlier I had said that we should not be drawing arcs in case of the pyramid problems, but here as all the points are belonging to the generators, even the arc technique can be used. So I have marked all the points over there. Now the question remains about the points which are to be marked explicitly, and those points are namely the point number 1 and 2. These 2 points which we have here, point number 1 and point number 2, which lie on CD and lie on AB, these points should be transferred to the development. And so on the development now, we are required to transfer first of all the distances from the top view. So I am taking the distance D1 in the compass, and from D towards C I should be marking it. So I get point 1, and then from A to 2 I am measuring the distance, and I should be marking it from A towards B. So I got those 2 points, point number 2 on the base and point number 1 of the base. Now the first point, which first arc corresponds to point number 6, second arc corresponds to point number 4, third arc corresponds to point number 5, and the last arc corresponds to point number 3. Point number 3 belongs to DV, so you can mark point number 3. Point number 4 belongs to EV, so you can mark point number 4. Point number 5 belongs to AV, so this is point number 5, and point number 6 belongs to FV. So this is how the points will be marked, and now we are required to join them in sequence. So it is point 1 connected to point number 3, then 3 is connected to 5, Three is connected to 4, 4 is connected to 6, 6 is connected to point number 5, and then 5 is connected to point number 2. Observe, the sequence will remain the same as we were having it in case of the front view that we have obtained. In the front view, we had the sequence as, you can observe that sequence, it is 1, 3, 4, 6, 5 and 2, and so on the development also you will be having the same sequence for the points. And once we complete this particular part of connecting the section part on the development, let us darken the portion which is remaining, and so these sides of the base are intact, they are not removed, so they should be darkened, and the portions of the generators which are still present, even they should be darkened. The problem is important because the view that we have obtained did not contain the true length, and true length construction has to be done separately somewhere, and so we get the development of that hexagonal pyramid. What remains now is to go for the dimensioning, and the dimensions which are to be given over here is first of all the height of that pyramid, which is given to us as 90 millimeters. So this dimension is 90 millimeters. Then the side of the hexagon, side of base of that hexagonal pyramid, which is given to us as 40 millimeters. Even that can be shown very easily. Then the angle made by the cutting plane, that angle can be shown with XY. And that angle is given to us as 30 degrees. And so the problem is now complete. We get the solution for the development in this case. So have a look at the problem very carefully. The procedure that we have followed. First we had started with the hexagon, then completed the front view. It was resting on triangular face, so it was rotated, then cut by AVP. Then we have completed the sectional view. Then we have obtained the true length of one of the generators, and these points are to be transferred. So I am as if taking it back to the normal position, transferring the points to the elevation and completing it. So a clean view of this particular figure. And then the development, and I had purposely chosen the points so that the development will appear in a continuous manner. Points on the generators of the pyramid, they can be marked directly by using the arc technique, whereas if the point would have been on the surface, I should have used some other method, that is drawing the lines parallel to the base of each triangle. Aiming will always help us to complete the problem correctly. One more problem on the development. This time it is going to be a prism which has got some circular hole, or we could be directly given the front view. The problem, it is a pentagonal prism of side of base as say 50 millimeters, pentagonal prism, side of base 50 millimeters, is resting on its base in HP, such that one side of base is making 30 degrees with VP. One side of base is making 30 degrees with VP. The height of the pyramid is 75 millimeters. The height of the pyramid is 75 millimeters, and it is cut by an auxiliary inclined plane, passing through a point on axis 10 mm from top, from the top surface, making an angle of 45 degrees with HP. Another AIP, auxiliary inclined plane, which makes an angle of 30 degrees, is passing through the point of the front view, through which the previous cutting plane is passing. Through which the previous cutting plane is passing. It also has a circular hole. It also has a circular hole of diameter 40 millimeters, passing through midpoint of the axis, such that the axis of that circular hole is perpendicular to VP, Draw the development of the lateral surface. Of the prism. So we will have to start with the construction of the pentagon in the top view, such that the side of the pentagon is 50 millimeters and making 30 degrees with XY line. The height of the prism is given to us as 75. So let us proceed to complete the front view. You will have to take all the points to the front view and take the height as 75 millimeters, which is given to us. So all the points should be transferred to the front view and should be going up to the height 75 millimeters. So take the projectors through each point of that pentagon which is drawn in the top view. So we are completing the front view part of it. But of course front view cannot be darkened because we are required to show the cutting planes. At the same time the axis is to be marked. So let us mark the midpoint of two sides of this pentagonal shape and connect it to the opposite corner to obtain the position of the axis. As we get the axis, even that can be transferred and it can be marked in the front view. The first cutting plane that is given to us is passing through the point on axis, which is 10 mm from the top and is making 45 degrees. So we can draw that cutting plane. So one section plane can be drawn. And it is said that the other section plane, which makes 30 degrees, passes through that point of the front view through which the previous cutting plane is passing. And so the second cutting plane can be shown in this manner. So this is how it is cut. Now there happens to be a circular hole of diameter 40 passing through the midpoint, whose axis is bisecting the midpoint of the axis of prism. length of the axis of prism is 75, so measure 37.5. that will act as the center of that square hole, or center of that circular hole, and the radius of that circular hole is 20. Diameter is 40, so radius is 20. Take a distance 20 and draw that circle. And so the circle will appear like this. Now this circle's portion is to be darkened, which is below the cutting planes. The portion which is above the cutting plane, that need not be darkened. So this is what is given to us. This is what is given to us in the problem statement. Now if we name the points, say A, B, C, D with our usual policy, and the points in the front view are A dash, B dash, C dash, D dash and E dash. And as we are looking from the front view direction, we can see generator A, B, C, D, and E will be the only one which is dotted, and so we can darken these generators which are visible. And this portion of the prism is retained. So we are through with the construction part. Now to draw the development, we are required to have in all 5 rectangles as the development of the pentagonal prism, each of side 50 by 75. So choose some reference line and from there mark the distance equal to 50. So we are required to mark the development in the form of 5 rectangles. We will be opening it from the nearmost generator, that is generator D. So this is going to be D, then E, then A, B, C and again D. Once the development portion roughly is drawn, we will go back to the front view and top view. And let us mark the important points. First of all, the point of the top. So the section plane is actually, 2 planes are cutting at this particular, these 2 planes are cutting at this particular line. This is the line of intersection of the 2 sections. So the points can be named as point number 1, which is on BC. Point number 1, which is on BC, and point number 2, which is on DE. These 2 generators can be easily marked so that I can complete the first part, that is showing the section planes. Now to mark these 2 generators, we will have to take the distances in the compass, that is from D towards E, D2 distance, and should be marked on the development as from D towards E to get point 2, and from C towards B, and from C towards B for point 1, and it can be shown on the development as from point C C towards B. So we got point number 1, generator for 1 and 2, and now those generators can be marked. So these are the 2 points of the top which are present. Let us proceed one by one. First of all, that 45 degrees plane which has been cut. First of all, that 45 degrees plane which has been cut or is cutting the generators. First generator that is cut is EV at this point. So we can draw the path and mark point on generator E. Then generator BV is cut. So even that point can be taken and marked on generator B. We get the point on generator B in this case. And then point on generator A. Point on generator A. So these points can be marked, and the first cutting plane will be shown in the section form as from generator A to point on generator B, from generator A to point on generator E, from E to point 2, and from point on generator B to point 1 of the top. And now the second cutting plane, which is cutting generator CV, and so that point can be taken ahead, and we get the point on generator C. And then generator D is cut at one point, so even the point on generator D can be taken and it can be marked on generator D, which is occurring twice, and again they can be connected. So you will have to connect them in sequence. And what we get over here is the development once the prism is cut by the 2 section planes. We can darken the generators which are not cut by the circle. Circle is cutting only generator E. So except that, other generators can be made dark. So this is how the development will appear if only the section planes were given to us. We can treat it as a sub problem, because only this itself will be a problem of development when the prism is cut by 2 cutting planes whose positions are specified. Generator E is yet to be darkened because the circle comes into picture, and to mark that circle, now there is a lot of construction which is to be made, and for that matter we will proceed with some more generators to be drawn on the front view. We will divide that circle into 8 parts. Generally it should be 12, but in this case it will be very crowded, so I am just dividing it into 8 parts. 4 are already there, so another 4 parts, so it is 8 parts. And then through these 8 parts draw projectors. Through these 8 parts draw projectors, and so you will be getting a number of projectors over here. And all these projectors should be drawn and should be pulled up to the top view. Should be pulled up to the top view. Also the 2 points at which the circle is cutting the cutting plane, those 2 generators also should be drawn. And even they should be taken all the way, and they should be taken all the way to the top view. And so the top view will now appear in this manner. So there will be so many points which will be coming, so many projectors which will be coming from the circle. Of course, we are required to name all the points of the circle and then name those same points even in the top view. So let us start numbering them. We have already used 1 and 2. So this is going to be point number 3. Then point number 4. Point number 5. Point number 6. Point number 7, 8, 9, and the 2 points of the cutting plane are respectively 10 and 11. Now to get those generators in the top view. So generator 3 will be present on AE as well as will be present on BC. Then generator 11 will be present on AE as well as BC. Then generator 4 is also present on AE as well as BC. Then generator 10 is present on AE as well as BC. Then generator for point number 5 as well as 9 is present on, so 5 as well as 9 is present on AE as well as BC. Then we have got points 6 and 8 which are present on DE as well as BC. And finally point 7 which is present on DE as well as BC. So there will be so many points which will be present in the top view. So all these points are now required to be transferred on the development on side BC, on side AE as well as on side DE, and these generators should be marked on the development. So let us take the distances one by one. From C towards B, take a distance equal to C3 and mark it from C towards B on the development. So on the development it will be from C towards B, generator 3. Then we have point 11. From C towards B, mark that 11 distance. Then take distance C4 and mark it from C towards B, C4. Then C10, mark it. Then we have C5. This is 5 as well as 9. And to mark this C6 and to mark now the distances which are pretty small over here, distance C6 and C7. Instead of taking these distances, I will take the distances from point B. So it is B6 distance which has been taken and should be marked on the development from point B. So from B, mark the distance for 6, and then B to 7 distance you take and mark it from B towards C. So on the development now, we are required to name all these points. So the sequence will remain the same. It is 3, then 11, then 4, then 10, then you have 5 as well as 9, then you have 6, 8 and 7, and also that we are required to draw their generators on the development. In case of prism, the generators are all parallel to each other, so all these generators should be drawn for each of these points. So this is so far as phase BC is concerned. Similar generators we also have on the two sides, namely AE and DE. So we are required to now take the distances, say from A towards E. Distance A3 is to be taken, and it should be marked on the development. It should be marked on the development from A towards E. It is 0.3. Then from A up to 11, take the distance, and from A towards E mark it. Then A4, so take the distance A4 and mark it. Then A10, take the distance A10 and mark it, and then A25, take the distance and mark it. So these are the distances which we have marked from A, and then we can mark the distances from D. It will be D to 7 from D towards E, and then D to 8. So D to 8. So these distances are marked, and again they are to be numbered. So this is 3, 11, then we have 4, then 10, then 5 and 9, then you have 6 and 8, and finally 7. And again all the generators should be drawn. So draw all the generators on the development for all these points. So this is one part of the construction, and now our job will continue from the front view only, because in front view now we have all these points. So let us draw the paths of all these points. This is path of point number 9. This will be path for point number 10. This will be path for point number 8. This will be path for point number 11. Then you have got path for point number 7 as well as point number 3. Then you have path for point number 4 and 6, and then you have path for point number 5. So all these paths should be drawn, and of course they should be extended even beyond, because we have got the same generators on the other side also for phase BC. So these are all to be extended. And we are required to find out the respective intersections also. So there will be complete mesh of horizontal and vertical lines, and now let us proceed one by one. Let us proceed one by one and mark the points. Point number 3 is on this line, and choose point number 3's position. You get point 3, 1 point, and you will also get point number 3 on the other generator 3 that is present. Then point number 4, which is this point, it should be taken all the way to generator 4 and should be taken ahead to generator 4 in the other view. Then we come down to point number 5. Point number 5 will go up to generator through 5 and should be taken all the way to the other plane also to mark point on 5. Then point number 6, point number 6 will go up to the generator through 6, and in the other case it will be generator through 6. Point number 7 will go up to the generator of 7, and in the other view it will be generator of 7. Point number 8, exactly on the same lines, 8 is to be marked, point number 8, and point number 8 in the other view, in the other plane, can also be marked. Then comes point number 9. Point number 9, topmost point, can be marked, and point number 9 on the other plane also can be marked. Point number 10 should lie on the respective intersections. Observe that here is the accuracy that we may talk of. Here is the accuracy that we may talk of, because it should belong to, generator 4 as well as path through generator 10 as well as path through 10 and on the straight line. This accuracy is something which is very important. Same accuracy you will be getting even on the other side. And then for point number 11, which is again exactly the same point that we have over here, and point number 11. Now these are the points which are to be connected by a smooth curve. Also the fact remains that we have missed the points on generator E, which are very close by. And so join these points by a smooth curve. There should be no corner. So one curve, and similarly there will be a curve on the other plane. and these two curves are not the symmetric curves as such, though both of them are bound to be ellipses. These are ellipses actually, but the planes which form them, they are not making the same or equal angle, and hence they will not be identical in the shape. And so the portion of the cutting plane between these two should be removed actually. That of course we can do it afterwards only. And so the development will appear like this. Now what remains is to darken the generator E, its remaining portion. And then the overall development will appear in this manner. This will be the development of that pentagonal prism, which is cut by two cutting planes. We are not completing the top view. Of course, time will not permit us. The naming again is playing very important role. It is the patience and the accuracy that will play very important role in this case. Line work also is very important. Dimensioning is the last part to be done. So you are required to show angle. I have already shown. You are required to show the angles made by the planes, which are 30 degrees and 45 degrees. Diameter of the circle can also be shown using some line. So I am taking some line over here and will be showing the diameter of that circular hole. So the diameter of the circular hole can be shown. It is phi 40. The height of the prism, which was given to us as 75, even that can be shown. These are all the dimensions which I am showing in the front view. So the dimensioning part is also very important. And in the top view, the only thing that is shown is the side of that pentagonal prism, side of the pentagon, which was given to us as 50 millimeters. That will be marked to complete the solution of the problem. No other dimension can be shown in the top view. Front view will contain most of the dimensions, and this will be the development, one of the very important problem as such. The solution will appear